Scalar triple product. So scalar triple product is represented here. A dot B cross C is equal to B dot A cross C is equal to C dot A cross B. So this is the way we represent scalar triple product. So consider B cross C equal to D. Then the result is A dot B cross C is equal to A dot D, which is same as scalar or dot product. So the product A dot B cross C is also called as scalar triple product or box product, which is denoted by in bracket ABC. So B cross C, you can just show it as this vector, unit vector I, J, K, and Px, Py, Bz, Cx, Cy, and Cz. So this is the way you can write B cross C. So A dot B cross C is equal to I Ax plus J Ay plus K Az dot. So now you can write this B cross C like that: I J K Bx By Bz Cx Cy Cz. So now just solve this determinant, just calculate the determinant and then just take the dot product with this quantity, that is A, vector A, which is represented as with its unit vector Iax plus Jay plus Kaz. So now we have this vector A, Iax plus Jay plus Kaz, and we just solved this determinant here, unit vector I and bycz minus cybz plus j, unit vector j, and cxbz. So this is cx and pz and bxcz plus unit vector k bxcy and minus b py. You can see here this is the case of unit vector when we just hide this column, unit vector column. Here is k and this is bxcy minus cxby. So it will be minus cx, this is minus cx and by, this is minus cx and py. So you can just correct it here, and after solving this we will have ax bycz minus bzcy plus ay in bracket cxbz minus bxcz plus az bxcz minus cxbz. So now you can see here in case of dot product I dot I j dot j equal to 1, but if the unit vectors dot product always will gives you 0. So it can be written in determinant form. A dot b cross c is, you can write it as ax ay az and bx by bz cx cy cz. So this is the way you can write this A dot B cross C, that is scalar triple product. And similarly you can write B dot C cross A, that means bx by bz cx cy cz ax ay az. And in same manner C dot A cross B, you can write cx cy cz ax ay az bx by bz. So it can be noted that from determinant theorem, if any two rows and columns is interchanged, its value remains the same but the sign changes. I can show you here. If B dot C cross A equal to minus determinant bx by bz ax ay az cx cy cz. So just interchange these this first row and second row. So when you will interchange the rows, this minus sign will become plus sign. Now this second row is the first row and the first row becomes the second row. So now it is ax ay az bx by bz cx cy cz. Same, c dot a cross b is equal to ax ay az bx by bz cx cy cz. So therefore the both terms are equal. A dot b cross c will be equal to b dot c cross a is equal to c dot a cross b. What is showing exactly? It is shows that in scalar triple product dot and cross can be interchanged without any effect on the result.